Hi folks, and this is Bruce. Welcome to my Black Hawk, Colorado Mountain Labs. And what I have to show you now is a Hewlett-Packard 3435A digital multimeter. This multimeter measures DC, AC, DC current, AC current, and resistance. And it does so over multiple ranges, and it does so beautifully. We take a little look at the unit. You can see that it's attractive. Got a nice handle on it. It's gotten a paint job, so it looks even nicer than it did. Let's see if we can... one-handing this thing, this is difficult. Here we go. And we have a serial number on it. It's a 1606A-10935. This particular unit did have a battery system in it, but the batteries had long since gone bad and had begun to leak. They had done no damage, but I did not. There was no sense in leaving them in there. They were just loading the power supply and taking the voltage down to the point to where the readout was dim, and so we solved all of that. We removed that and added the jumper that makes it a strictly an AC bench unit. That would be an option 1 for this particular multimeter, and we're going to take it through its paces, and we're going to show you that not only is it attractive after all of these years, but it's quite functional. We're going to do the performance tests that come right out of the manual for all of the functions. So bear with me and we'll get started. It is kind of long and it is tedious, and if you want to skip through it, I totally understand. But I would imagine that if you're considering buying this unit, you're probably going to want to see it. So, thanks again. Okay, we've got the HP3435A connected up in DC voltage mode on the 200 millivolt scale. We've connected it to this Fluke 343A DC voltage calibrator. We're putting in 10 millivolts right now. That 10 millivolts is registering on this HP3441A, and we are reading 9.8 millivolts, which I've entered into my calibration sheet here. And if we're between 9.8 and 10.2, we're good. We're at 9.8, so we're good. If we go to 50 millivolts, and we confirm that we're at 50 millivolts here on the HP, we're getting 49.8. I've entered 49.8, and I got, if you're between 49.7 and 50.25, you're good. Next, we go to 100 millivolts. There's 100. 100 verified. We're getting 99.8. I've entered 99.8, and if we're between 99.7 and 100.3, we're good. So we're good on the 200 millivolt scale. We're going to the 2 volt scale. With 100 millivolts entered, we have 0.1 volts. Enter 0.1 here. If we're between 0.099 and 0.101, we're good. If we go to 0.5 volts, verify that we have 0.5 volts here on the HP. We're getting 0.500. Enter 0.500. If you're between 0.498 and 0.502, you're good. Now we go to the 1 volt scale. Verify that we have 1. Verify that we have 1 here. 1.000. 1.000. If you're between 0.998 and 1.002, you're good. Well, we're great. That's the 2 volt scale. Now we go to the 20. 20 volt scale, we want 2 volts to start with. All right. 2 volts. 2 volts. 2.00. If you're between 1.99 and 2.001, you're good. 5 volts. Verify the 5 volts. We're getting 5.00. If you're between 4.98 and 5.02, you're good. Now we go to 10 volts. Verify the 10. 10.00. Flashing 01. But I'm going to call it 10.00. 9.98 to 10.02, you're good. So we go to the 200 volt scale. And we start with 20 volts. In order to get 20 volts, I'm going to have to raise my range. We'll go to the 100 volt range. There's 10 and 20. Verify that we have 20. And we see we have 20.0. 20.0. If you're between 19.9 and 20.1, you're good. Go to 50 volts. Verify we have 50. Verify we have 50.0. If you're between 49.8 and 5.02, you're good. Now the 100 volts. 100 volts. 100.1. If you're between 99.8 and 100.2, you're good. 1200 volt range. 200 volts on the input. I'm going to have to change my range once more. We're going to the 1000 volt range. And we want 200 volts. 200 volts DC. Getting 200 on the meter. Reading of 200. If you're between 198 and 201, you're good. Go to 500 volts. $499.99, 500. We're getting 500. If you're between 498 and 502, you're good. Finally, 1000 volts applied. All right. $999.99. Getting a reading of 1000. Reading of 1000. If you're between 998 and 1002, you're good. So, on all of our DC voltages, we are within the specs. All right. Let's move on. Okay, well, we're here with the HP3435A. We're at this point measuring AC voltage. We're in the 200 millivolt scale. We're getting our voltage from this Fluke 5200A. Right now it's 10 millivolts at 30 hertz. And we're reading 10 millivolts on the 34401, which is our little verification tool. And right now we are reading 9.9 millivolts on the 3435. So let's enter that. 9.9. If we are between 9.5 and 10.5, we're good. So we're good. Now we're to raise the frequency up to 50 hertz. Okay, 30, 40, 50 hertz. And reading 10 millivolts. And we're reading 9.9. If you're between 9.7 and 10.3, you're good. Now we want to go to a kilohertz. Alright, we want frequency range to go up. We are reading 10 millivolts. We're getting a reading of 9.9. If you're between 9.7 and 10.3, you're good. Want to go to 10,000 hertz. We are reading 10 millivolts, 9.9. If you're between 9.7 and 10.3, again, you're good. All right, we want to go to 20 kilohertz. Change our range again. 20 kilohertz. Still 10.00 millivolts, 9.9. If you're between 9.7 and 10.3, you're good. 50 kilohertz. 30, 40, 50. 10.00. 9.8. We dipped just a little bit. But if we're between 8.8 and 11.2, we're good. 100 kilohertz. 100 kilohertz. 10 millivolts. 9.7. 9.7. If we're between 8.8 and 11.2, we're good. Okay, now we want to apply 50 millivolts. Go back to 30 hertz. 30 hertz. Okay, 50 millivolts. 50 on the scale at 30 hertz. If we get 49 to 51, we're good. Want to go to 50 hertz. Let's see. Yeah, we're going to have to change the voltage either way. Go to 50. 50 hertz. 50 millivolts. 50.0.1. Call it 50.1. If you're between 49.5 and 50.5, you're good. 20K. I want to go to 20 kilohertz. 50.0 millivolts. 50.1. If you're between 49.5 and 50.5, you're good. 100 kilohertz. 100 kilohertz. And we are at 50.05 millivolts, 50.0, 50.0. If you're between 48.2 and 51.7, again, you're good. Okay. Want to go to 100 millivolts at 30 hertz. All right, we're getting 100 millivolts, and we're getting 100. About 100 even. .98.2 to 101.8 is good. Now we want to go to 50 hertz. Okay, 100 millivolts. 100.0, 100.1. We'll call it 0.1. And that's at 50. It says or 500, so we'll go to 500 as well. Alright, that's 500. 100.00 millivolts. 100.1. If you're between 99.4 and 100.6, guess what? Alright, let's go to 20 kilohertz. We're getting 100.00 millivolts, 100.3. So if you're between 99.4 and 100.6, good. Go to 100 kilohertz. Okay. All right, 100 millivolts, 100.2. 100.2. If you're between 97.5 and 102, you're good. We're very good. All right, that's the 200 millivolt range. Now we go to the 2 volt range. We want 1 volt, 30 hertz. 1 volt, 30 hertz. All right, 1 volt. 1 volt. 1.000. If you're between 0.982 and 1.018, you're good. 50 hertz. 1.0003, 1.001. And let's see if it holds that up to 1K. It says at a kilohertz we should be doing the same. Okay. All right, we got 1.0003, 1.000, 1.002. If we are between 0.994 to 1.006, we're good. Okay, 100K. Oh, excuse me. That was 1.001 to 2. Now we got to do 20K. All right. All right, we got 1 volt. We're getting 1.002. Yeah, that's good because if we're between 0.994 and 1.006, we're good. We go to 100K. 1 volt. 1 volt. 1.000 if we're between 0.975 and 1.025. 20 volt range. We want 10 volts at 30 hertz. Okay. All right, 10.000 volts at 30 hertz. We're getting 10.00. A little bit of noise, but 10.00. If we're between 982 and 1018, we're good. If we go to 50 or 10,000, I'm going to go to 10,000. Let's set it there. We have 10.000, and we're getting 10.02 at 10 kilohertz. If we're between 994 and 10.06, we're good. 20K. $20 kilohertz, okay. We're reading 10.000 100.6. We're getting 10.02. 10.02. We're between 9.94 and 10.06. We're good. Finally 100K in this range. Alright, we've got 10.000, 10.01 at 100 kilohertz. We're between 9.75 and 10.25. We're good. 200 volt range. 100 volts applied at 30. Alright. 100.003. 100.0. Yeah. Bouncing between 99.9 and 100.1, but 100.0. So 100.0 at 30 hertz. If we're between 98.2 and 101.8, good. Let's go to 15,000 hertz. All right, we got 100.001, 100.1. 100.1 at 15 kilohertz, 15,000 kilohertz. If we're between 99.4 and 100.6, we're good. Let's go to 20 kilohertz. Okay. 100.002, 100.1. 100.1. We're between 99.4 and 100.6. We're good. 100 kilohertz. Okay. 30, 40, 50, 60, 70, 80, 90. 100 kilohertz. 100.001. 100.0. We were between 97.5 and 102.5. We're good. Okay, now we got a problem. Because now they want us to develop 1,000 volts. And in order for me to do that, I would have had to have invested another $1,000 in a power amplifier for my AC generator. And since I didn't do that, I cannot provide 1,000 volts. I can go to the 1200 volt range and I can provide 110. Hertz. I can give us 110 volts at 30 hertz on the 1200 volt range. All right, and we'll have to make a special note here. So we did this at 110. At 30 hertz, we got a reading of 109. At 1 kilohertz, 110.00, I'm getting 109. And at 10K, at 10K, 110.001, 109. Okay. So we read 109 volts in from 30 hertz to 10 kilohertz on the 1200 volt range. And we'll check that out as far as, I believe that to be right in the middle of the range anyway, reading wise, but wish I could provide the 1,000 volts. I'd like to have done this 100% the way that they required in the manual. But that's it. Let's move on. Okay, well, we've got the HP3435A connected up to this resistostat 2 resistance box, which contains 0.01% resistors. So we're not talking 1%, we're talking 0.01%, 1/100th of a percent in error tolerance. So anyway, right now we're on the low end of the ohms, or 20 ohms, and we're following the performance testing guide sheet right out of the manual. And on 20 ohms, we're to apply 1 ohm, and we are to record the reading, and we've got a reading of 1.03. And we will write 1.03. We're good if we fall in a range of 0.89 to 1.11. So we are smack in the middle, and that's very good. Let's go to 5 ohms. 2, 3, 4, 5. We got a reading of 5.04, and we are to be between 4.87 and 5.13. So 5.04, again, right in the middle. Let's go ahead and apply 10 ohms, the next step. And we got 10.04. 10.04. Now there's a theme running here. We see 0.03, 0.04, 0.04. That's because our leads and our contact resistance at the post, and even though we have excellent contact on the switches in this box, we've got 0.04 ohms, essentially 0.03, 0.04 that we're picking up in that resistance. Kill that and you're dead on. But anyway, we are still smack dab in the middle. Let's go on to the 200 ohm range. And 200 ohms, we want 10 ohms to begin with. All right, we're reading 10.0. 10.0. We're to be between 9.8 and 10.2. No problem with that. Let's go to 50 ohms. 20, 30, 40, 50. We've got 50.0. 50.0. We're to be between 49.7 and 50.3. No problem. Now we go to 100. And we are reading 99.9. If we are between 99.6 and 100.4, we're good. And again, we're pretty much in the middle. Now we go to the 2K range. And in 2K we want 200 ohms. And we have 0.2K, that's 200 ohms. So let's 0.200. We're to be between 0.198 and 0.202K. We are smack in the middle. Go to 5, 3, 4, 5, 0.500. Can't fault that, that's dead on. 0.497 to 0.503K would be the range. We are smack in the middle. Now we want to go to 1K on the resistance. There's 1.000. And oh, for some reason I didn't copy that down, but we're going to be smack in the middle of whatever the range is anyway. I'll look it up in a little bit and add it. If we go to the 20K range, we want 2K on the input. Just put 2K on there. I got 1.99 to 2.00. I'll write 1.99. If we're between 1.98 and 2.02, we're good. We know we're somewhere between 1.99 and 2, so we're great. Let's go to 5. 5.00. And we're to be between 4.97 and 5.03. Again, perfect. All right, now we want to go to 10K. 10K, 10.00. Okay, 10.00. We're to be between 9.9 to 10.04. We're perfect. And we will go now to the 200K range. And on 200K, we want 20K resistance. So here we go to the 10K. There's 10K, 20K. 20.0, 19.99, 20.0. So we'll call it 20. If you're between 19.8 and 20.2, you're good. 50K, 3, 4, 5. 50.0. If you're between 49.7 and 50.3, you're good. Now we're going to go to 100K. 100K, we get 100.0. 100.0. If you're between 99.6 and 100.4, you're great. Now we go to the 2 megohm range, and we want 200,000 ohms, and I am reading 199 with a flash to 200. We'll call it 199.5. How about, well, that is what it would have to be, but we'll give it 199. If we're between 198 and 202, we're great. 3, 4, 5. Now we're 500K. We got 500K. If you're between 497 and 503, we're good. Now we want 1 million. There's 1 million. We got 1,000K. And if you're between 0.97 and 1.03, you're good. Now we've got to switch resistor boxes because we're going even higher in the megohm range. So we'll pull out this one. And we'll insert this one. Okay, we want 5 megohms. And we want to be on the 20 million range. Excuse me. First we want 1 megohm. And we're getting 0.99. If you're between 0.97 and 1.03, you're good. 5 megohm. And we are getting 4.98. If we're between 4.94 and 5, we're good. Finally, 10 megohms. All right, we're at 10 megohms. 9.96. If we're between 9.90 and 10.1, we're good. And we are right in the middle of that, so we're doing great. Okay, So it looks like the resistance performance test we passed with flying colors. All right. Okay, well, we've got the HP3435A connected up in DC amps mode, and we're on the 200 microamp scale. We are feeding in a current generated by a 1 volt source through a 100K resistance that is 0.01% in tolerance. We are measuring 10, actually 0.01, that's 10 microamps of current. And we are getting 9.8 out of the digital multimeter, which we're going to enter in here on the table. 9.8. If we're between 9.8 and 10.2, we're good. Now we go to 50, which means we raise our voltage to 5. Yeah, we adjust for 50. All right, 50 microamps. And we're getting 49.9. 49.9. If we're between 49.6 and 50.4, we're good. And we go to 100, which means we pull up 10 volts. And we're getting 99.8. 99.8. And if we're between 99.5 and 100.5, we're good. So we go now to the 2 milliamp scale. We put in the 0.1 milliamps, which is 100 microamps, so essentially where we were. Alright, there's 100 microamps. We're getting a reading of 98. We put in 98.098. For 0.098 to 102, we're good. Alright, we adjust now to 0.5 milliamps. 0.5 milliamps, we're reading 0.497. So we're reading 0.497. If we're between 0.496 and 0.503, we're good. Now we go to 1 milliamp. 0.999. So 0.999. If we're between 0.995 and 1.005, we're good. Now we go to the 20 milliamp scale. And we want 1 milliamp here as well. And we are reading, we're reading 0.98. If you're between 0.98 and 1.02, you're good. Now we go to 5 milliamps. 5.007. We're reading 4.99. 4.99. It's between 496 and 504. We're good. Alright, we want to go to 10 milliamps at this level. That means 10 volts. 10.004, 10.00. We're good. Alright, we want to go to the next scale, 200 milliamps. And we're going to reduce our resistance to 10 ohms. 10.011. We're reading 9.8. 9.8. You're between 9.8 and 10.2. You're good. Alright, we want to go to 50 milliamps. 50.0. 49.8. If we're between 49.6 and 50.4, so we're good. 100 milliamps. Okay, we got to go 100.0. 99.8. We're between 99.5 and 100.5. We're good. Finally, on the 2000 milliamp scale, we want 100 milliamps input. 100.2.1, 100.0. We're getting 97, 98. 98. You're between 97 and 103. You're good. Now we go to 500 milliamps. Right there's 0.500. We're getting 498. If you're between 495 and 505, you're good. Finally, we need 1,000 milliamps. That's a biggie for my poor resistors. 1,000. 999. If you're between 992 and 1,008, you're good. So there we go. Our DC amps are reading right within spec. We'll move on. Okay, well, here is one of the more difficult parts of testing this unit. We're going to be looking at the AC ammeter functions. It means we have to provide precision AC voltages. We have to find resistors that are not wire wound, that would not present a problem as far as inductance and impedance. So we're going to do our best. We have right now a 100,000 ohm 0.1% resistor wired up in series with the power supply. We are feeding a 1 volt signal through it at 30 hertz, or at least we will be as soon as I throw the switch. We're on the 200 microamp scale, and I am looking to see 10 microamps show up on it. So here we go. Operation, and we see 9.8. Okay, well, according to the manual, if we're between 9.4 and 10.6, we're good. And 9.8 puts us right in the middle, so actually we're very good. So 9.8. microamp. Okay. Then it wants us to go to 50 hertz and then 10,000 hertz. 50 is easy enough. 40, 50. We're at 50 hertz right now. We didn't change at all, so 9.8 again. Microamp slash, and we're going to go to 10,000 hertz. Okay, so we have 1 volt AC at 10 kilohertz, coming out of the Fluke 5200A, and we are running that through a 100 kilo ohm resistor per the requirements of the test, going through the ammeter, and I'm verifying that the voltage coming out of the unit up there is 1 volt, and we are 1 volt to 5 places right now, or well, 4 anyway, 4 plus. And we're getting 9.8 microamps at 10K. So again, 9.8 microamps, which matches our 50. All right, now we want to go to the 2 milliamp scale. And I'm going to want to put on 10 volts and 30 hertz. So first we got to go off into standby. Then we want to go up. There's 10 volts. I'm going to come down in frequency. And there's 30 hertz. Everything looks good. Operate. Okay. We are getting 0.099 milliamps. So 0.099, approximately 0.1, but let's see. We're supposed to get 0.1 milliamps. And if we read between 0.094 to 0.106, we're good. We're almost dead on. So, perfect. Okay. Then we go to 50 hertz. No effect at all. 0.099 milliamp. And at 10K, we'd like to read the same thing. Let's all right, there's 10 kilohertz, 10 volts. We're in operate mode. All right, 1 volt to within 5 places. We're getting 0.099, and that is exactly what we had. Interesting. Okay. 10 volts. We did that. 20 milliamp scale. Okay. We want 10 volts at 30 hertz, and they want us to reduce the resistance to 10K. Let's go off. $10K. We want 10 volts across the 10K resistor, and we want it at 30 hertz. Our voltage is a little low. We'll bring her up. Okay. And we're getting 0.99. So 0.99. We're good if we're between 0.94 and 1.06. So perfect. If we go to 50, don't expect any difference. 0.99. 0.99. And then if we go to 10K, and we've got to bring the voltage down a little bit, or excuse me, 10 volts, 10.000. and we're getting 0.99. So beautiful. Huh. It's even better than I thought. 20 milliamp scale. I'm sorry, 200 milliamp scale. And we've got to stop. Okay, well, we've got the HP hooked up in AC amps on the 200 milliamp scale. We're feeding 20 volts, 60 hertz from the Fluke 5200A through a 1000 ohm 3 watt resistor, which is better than 0.1%. We've got 20 volts measured to within 3 decimal places, and we get 20.0, which is perfect, coming out. Now we want to try 50 milliamps, and we'll have to see what we can do here. Okay, well, we're going to try and test for 50 milliamps. We're on a 1000 ohm 3 watt resistor. We're air cooling it. We're feeding in 50 volts at 60 hertz, which will generate the 50 milliamps that we're looking for. I want to do this very quickly because that resistor is going to get hot. I don't want to burn it up. So let's give it a go right now. 50 volts, 50.4.5 milliamps. Okay. So according to the chart, if we're between 49.1 and 50.9, we're good. I'm going to call it 50.5. So 50.5 milliamps. Okay. That was 2.5 watts we generated, I think, on that resistor. If I go to 100 milliamps in the same resistor, we're going to be at 5 watts and I'll blow it up. So I can't do that. So we're going to have to try and measure the 100 ohm resistance that's in here. And I'm going to take a moment and calculate. Okay, well, I had to do some checking. I looked up the specifications on my 5200 AC calibration device, and the maximum output is 50 milliamps. And after that, I get current sensing that kicks in, and the voltage gets limited, and I just can't put out the current for the last range, the 2 amp range. They wanted me to provide 100 milliamps, 500 milliamps, and 1000 milliamps of current. And even the lowest one is double the current rating, then it's 10 times, and it's 20 times. So I can't do it. I'm not going to blow up my my calibrator. And unless I come up with another way to generate the AC voltage I'm looking for, like maybe a variac or something, I guess I'm not going to do it. Everything so far has passed with flying colors. I really don't see any reason to believe that the last range won't also, if I could just provide the voltage necessary, well, or the current necessary. So I'm going to call it quits at this point and go ahead and put this unit up for sale. And I'm going to wish you all happy bidding, and thank you for listening. If you